And good afternoon. It's good morning somewhere. This is the PFG Live. Welcome aboard.
That was easy.
So we have our first report in from Mr. Warren Jones, who says hello. It's raining and 45 degrees here at World Headquarters, 50 miles north of you. Thank you, sir. And the test pattern is working perfectly. Outstanding. Jeff Lawford is here, cloudy and 39 degrees in Wasilla, Alaska. I know where that is. Well, nice to see you all. Actually, it's Jeff, it's morning for you, right? So good morning. We'll say good morning. It feels like morning when we do this, even though it's afternoon. Wes says it's supposed to be 85 here today. You didn't give your location, so it doesn't count. I mean, I know roughly where you are, but that's crazy. I'm wearing the sweatshirt. I actually was not wearing my sweatshirt, and I elected to get up and go get the sweatshirt because it's a little chilly in here. CJ Stevens reports 68 and sun shining in the east of Tennessee. Welcome aboard, sir. Dan is in the office. He says, cold and rainy here in the office overlooking Mass Ave toward the bridge. Wow, you have a good... Oh, I know where you are. Okay. Preparing my plans to show Sally the new president when she visits Thursday. Is she visiting your lab? That's awesome. Maybe I'll come down. Start trouble. Kevin Blodgett reports 58 degrees and cloudy but dry in Oregon. Now, when it's dry in Oregon, you'll note that they're always careful to report that. Robert Simpson reports 51 degrees and rainy near Detroit. We're not saying in Detroit. And Wes is on planet Earth. Sometimes I'm not certain. Thursday 4 to 5. Oh, jeepers. Okay, I'll see what if I can pull something off. Thursday 4 to 5. Are you going to be running around like a chicken with your head cut off, or should I kind of sneak in and sneak out, or should I show up early? I don't know what's going on Thursday, so I'll have to check. Give me either private message me your room number. Yeah, don't do it here. Private message me your room number. I think you've done it before. Anyway, welcome aboard. Dan and I speak a secret language that involves beavers. Don't judge us. Anyway, I hope you guys are having an awesome weekend. It is, in fact, raining here in southern New Hampshire, and it is 49 degrees Fahrenheit. And it was raining earlier. It still looks like it's drizzling. We need it because we're trying to grow grass in the yard. 35, 112. Okay. I'm writing that down. Excellent. Let's see. Busy week, huh? It was a little bit of a crazy week here. I finished the video on the grippers, and I released the video. And once again, it reinforces how much work a video is. It's a lot of work. I didn't quite pull an all-nighter, but I was up till 2 a.m. getting that thing out. Primus had a song about such mammals. Well, they are mammals, but they're also the engineer of the animal world. And Dan knows who I'm talking about when I report that there are some animals in the engineer world. So, yeah, I hope you guys had a fun hands-on shop week. Got the video done on the grippers. Got the grippers done. That was huge. Ready to start getting back into making the B200s, the balancing rings, because my wonderful customers cleaned me out. But we're about to hit it. And I'm looking forward to applying, that was about a year ago, I think, the last batch. And I'm looking forward to applying a year's worth of learning to the new batch. And also maybe some things in Fusion 360 that are a little smoother. Oh, Kevin, that's such a nice thing to say. Kevin says, that video's quality editing showed through. The results are worth it. Thank you. Would you like to know what I learned from that edit? Not in the order, in any particular order, but indicators blow out. They're really hard to read. So the next time I'm doing a shot where the indicator itself is important for the viewer to see, I will do an exposure compensation. And that's an important thing to do, because the camera is trying to make the exposure good, overall, and the indicators always blow out. I know that Tom Lipton, Ox Tools, tried to solve that problem, and I think maybe kind of solved it. Bar Z Industrial, Stan Zinkowski, he also started putting like green tape over his indicators. But anyway, I forgot what others already knew, and the indicators blew out. The other thing is, I have to go to manual focus for those shots in the machines and in the grinder, because what I'm finding is that the camera, which has got all sorts of smarts in it, is trying desperately to focus on the right thing, and when we're doing grinding shots, it has no earthly idea what to do. Hey, there he is. Machine Tech Video Blog, also known as Adam B, says, always buy black dial indicators for filming. I think I might own one. That's it. I think all my other indicators are white. We'll figure it out. We'll sort this out. But it's just one of those checklist items now that's in my head. So we'll sort that through. But getting that project done, in addition to getting the editing done, which was fun, but it was a lot of work, was super. I really enjoyed it. And I particularly enjoyed the heat treating learning. There was some interesting stuff that went on, and I have some of them here. Actually, I have all of them here that aren't in the machine. Here's one of the grippers, and it just came out so nice. And it's Rockwell 60, and that sharp edge is sharp, really lovely. So I'm looking forward to getting that into production. By the way, I wanted to talk a little bit about. I didn't do this in the video because I didn't want to get into it. But these are the grippers that Mighty Bite. Come on, UFAC, you can focus. There we go. That Mighty Bite sells with the VersaGrip system. And the interesting thing is that as I said in the video, the work sits on top of the jaw for Z reference, and then it gets shoved into the gripper. So it makes it a shorter part, but also the hardness of this part is Rockwell 55, C55. And on this particular one, let's see if I can show it to you on the video. For those of you on the blog, you'll just have to take my word for it. I dented or bent the tines on this gripper when I was using it. Not particularly on the balancing ring project, but on other projects. So I attribute that to a couple of things. One is it's a little softer. Rockwell 55 is not, super soft, but it's probably 4140. It's tough. And I wasn't controlling my my pressure on these things. So we've learned, and now I'm controlling the pressure through a torque wrench on the vise. The part is a little bit harder. It's going to be awesome, and it's also a lot sharper. So that'll be great. So I'm looking forward to doing that. I'm looking forward to cranking out some balancing rings. I'm going to do a batch of 100. I might do a batch of 200. That might be the smart thing to do. So we'll see what happens. But I do have the material for 100 in-house, but getting the rest won't be hard. So that's a story on the grippers. Fun project. But it uncovered a bunch of heat treating things. Okay, so it was the first time I ever purged a heat treating envelope with argon, and it was very interesting. So this is leading me to want to do an experiment. And Mr. Kevin Blodgett, who is present, no need to stand, is going to be very excited about this. So I'm going to be cutting some 1.25" discs out of A2, and there's a few. I'm going to do a couple of things on it. I'm just going to skim the outside diameter, drill and tap a 1/4 hole in the center, and the rest is grinder work. So then we're going to have a bunch of these discs for heat treating, and I'm going to turn that into an experiment, and I want to talk about that a little bit. I want to experiment with argon purge in the envelope versus no purge in the envelope. Okay, that's one of the things I want to do. I want to experiment with a couple of different tempers. So when we did the grippers, okay, we did a 500 degree Fahrenheit temper, and we did it twice. So 500 degrees back to room temperature, 500 degrees back to room temperature. And the Rockwell testing indicated that worked out pretty nicely. So we got a solid Rockwell 60. I took 3 measurements on my sample part. They were dead on. The weird thing was when I did a single temper, and I can't explain this, so this could have been just operator headspace, but when I did the single temper, I got a very noisy measurement. I actually took 4 measurements because it didn't make, something wasn't right. So it's like chicken soup. The double temper can't hurt. And it came out really nice. So I'm probably in the double temper camp. So we'll do a couple of tempers on these discs that I'm talking about. We'll do a 500 degree and we'll do a 400 degree. And I might get frisky and do a 300 degree. I think 350 might be considered the lowest recommended for A2 tool steel, but we'll check it out. So we have a little experimenting we're going to do. When we're all done, all of them will be usable for the application, which I'll explain in a second. But I will report. I'll report back my results. The other thing that I found fascinating, and I had commented on this before, was that the data reported in the data sheets is all over the place as far as dimensional changes, as far as toughness versus temper. It's very difficult. So I think the data sheets are at best a guide, and you have to do these experiments if it's a critical part of your process. Are we doing critical work? It's, we're not sending rockets to Mars, at least not at the moment from my shop. So we'll see what happens. We'll have some fun with the heat treating. But I'm interested to hear from you guys if you are doing heat treating in your shop, what materials you are heat treating, and what your recipes are. And we could do that here in the chat, or you could send me a message, and I'll compile the information. But I think getting a consistent recipe that works is an important thing. Anyway, we'll see. I also had some fun learning the history of A2 tool steel. It's actually a very, very old tool steel. So that was an interesting read. And that came from Laren Thomas's blog, Knife Steel Nerds. And that was worth learning something about. I wanted to comment on something that I didn't get into the video. In the video, you're going to see a shot where I have a fan pointing into the oven. So I have 2 ovens, and the left hand oven is the new one, and that's doing the heat treat high temperature, and the right hand oven is the tempering temperature, which is 500 degrees, relatively low. I would never, ever, ever point a fan into an oven that has red hot coils for cooling. You will destroy the coils. The heating coils are not meant to be cooled off that fast. This is the primary reason I have two different ovens. One is for the high temperature austenitizing part of the heat treat process, and the other one is for the tempering. This is so that I do not have to wait for the temperature to come down on the hot oven. If you try to cool that oven down quickly so that you can get to your tempering, you're going to destroy your heating coils. So when you saw a shot in that video of a fan pointing into my right-hand oven, which is the classic Barzi Industrial hot shot, that was not only was it at the 500 degree temperature, but it was already mostly cooled off. It was below 200 degrees, and I was just bringing it down to room temperature. So I just want to clarify that, because I don't want anybody to point a fan into their heat treating oven to cool it off so they can get to tempering. That would be very bad. So I hope that's pretty clear. Thank you to Robin Renzetti for kicking me in the butt and making me get a fan going. That worked out really nicely. Oh, that was the other part of the experiment on the next go-around. I had reported that the the argon purged envelope did not get that vacuum-packed look, right? Which I have suggested was due to the consumption of oxygen in the bag. Carl says, I'd be more worried about the refractory than the heating coils. That is a valid argument. I do not want to experiment with either. So that's why we separate the process. But yeah, I agree with you. And if you have a good electric oven in the kitchen, and we have a really nice electric oven, and I have tested it, and it's extremely accurate. You could use your oven in the kitchen for the low temperature tempering. Yeah, that would work just fine. So the other experiment is I want to see the difference in that vacuum packing phenomenon, that where the air, it looks like the air got sucked out of the bag, and my theory is that because it was the oxygen getting consumed by the 309 stainless envelope. So having two bags go through the same process, one that's full of argon and one that has the normal amount of air in it, that will be very interesting to me. And then also looking at the color of the bags. The other thing I'm going to do is I'm going to force myself to absolutely not open the bag too early. And I think I did that on the gripper project. And it didn't hurt. It actually made this very nice looking oxide layer that I later proved was very, very thin. Okay. And you can see it in the groove there still, because we ground off, and there's a little bit on the chamfer. When I stoned it, I was able to stone through it reasonably quickly. Like, it was not very thick. But I want to see if I force myself to absolutely not open the envelope. In fact, I want to leave it closed for the whole process and trust the fact that our very good fan is going to get the thing cooled off in the air quench sufficiently quickly. I'm very interested to see how clean the parts come out, especially with the argon purge. So these are all questions I want to get answered on this next go around. And when we're all done, we're going to have these hardened discs that we're then going to turn into basically flat files using laser technique. And Mr. Blodgett has the application for it. So if we're successful, he will be the beneficiary of some really cool tools for working on brass instruments. So this is, originally Kevin and I had talked about, well, let me explain. I know I've explained it before, but let me explain the application. The application is imagine a saxophone, and Kevin, you can hit me in the head if I get this wrong. You've all seen the valves on brass instruments, and on a saxophone, those big valves are flapping in your face. So when Kevin is a master of rebuilding brass instruments, and when he surfaces the face of that valve, he wants to get it really flat. Yes, he's excited. So Kevin had asked me a while back if I could make a PFG stone to do that. The problem is, and the answer is yes, there's a couple of things to consider. Number one, Kevin's instruments are brass. It's a soft material. Okay, no problem. So Adam Demuth had asked me a while ago to make him some little 2-inch round stones for some work he was doing, again, to get into a small space. And I did, and they're actually standard products now. We call them the roundels. And if you can tell me why I call them the roundels, besides the fact that they're round, you're going to win a Cupid doll. But the problem is that Kevin has multiple sized holes that he's dealing with on these instruments. So anyway, that's problem number one. Problem number two is the brass is soft. We could make what is essentially a flat file. And then I did an experiment. I think this is the first time I've talked about this publicly. I did an experiment with the laser to essentially cut a flat file. And there's some reasons that you could imagine why, maybe this isn't going to work. And it showed signs of working extremely well. So we're going to do that. And in the end, we're going to have the ability to make these round flat files specific to his application. More on that later, because I think that's going to be a fun project, and we'll get a chance to talk about that. But it's going to combine heat treating, grinding, laser work, and then, Kevin's expertise. It's going to be very cool. I went so fast, Wes, I missed which one you're referring to. Feed the name back to me. And the answer, and even before you do, I did play bass for them in the 70s, and poorly. And full disclosure, I did play bass in the 70s. In fact, I think I can correctly say, I'm thinking about this. That is, in fact, don't tell anybody, but that's the last time I played bass. And it was the upright bass, and it was classical, and it was the 70s. And somewhere around 80, I actually gave it up. But I lie about it constantly, so why not? I'm going to take a sip of tea. Oh, the roundels. Yes, the roundels. We had a sound that was ahead of our time. Oh, I know what you're thinking. You're thinking, if you're watching the video, of course, if you're listening to the podcast, you're shit out of luck. But if you're watching the video, you're saying, what is that you're holding? And Chris isn't here. Oh, is he here? No, Chris isn't here. So you might notice that our pet laser shark is on this here tumbler. So one of the projects this week was, in fact, hang on, I got to silence my watch because Jay, who should be watching the video, is going to send me. He's going to send me messages here. There we go. One of my projects this week was to get the recipe sorted out for laser engraving on a powder-coated stainless tumbler, which is what this is, a powder-coated stainless tumbler. So we used our Laser Shark, and some of you might have gotten the Laser Shark, where is it? We have a Laser Shark sticker right there. And now we have successfully put it on a tumbler. So if I turn this around, you'll know that this was prototype number 1, because you see you see the self-documentation on the tumbler. And yeah, did a bunch of experiments, got it working really well. We may come out with some merch for PFG Stones in the form of a tumbler. So if you're interested in that, let me know. We have our best artists working on it. Anyway, so there you go. So, well, let's see. We did lasering this week. We finished the grippers this week, and we're planning this heat treating experiment. Are there any other aspects of this heat treating experiment that I should be considering? There's a question for you. How'd you like the rotary grinding? You know, it's funny because as I went into that project, I said to myself, "Oh, I should grind it all over." And they said, "No, I can get away without grinding it on the OD. I'll just, I'll turn it and it'll be fine because it's just going into a hole and I just need a certain." And sure enough, I blew the dimension and ended up having to grind it anyway, which turned into a great learning experience again. And we did the rotary grinding, and that's what's in the video. So that was a lot of fun. So that's the story for this week, and upcoming projects. And I will talk more about B200s in the upcoming weeks. My plan. Oh, and I've been getting a lot. Let me address there's a 800-pound elephant in the room, which, by the way, if you think about it, is a pretty small elephant, but it's still in the room. I've been getting requests for the balancing stands, and that has been starting to exponentially increase. So it is my next major project. I will get the balancing stands out. I would say my design is about 75% done, so I just have to bring it in for a landing. Also, we're going to do another experiment. We're going to open source some of the balancing stand information. So when we're all done, you can buy a balancing stand from Kinetic Precision, or you could build your own, and that's fine. Of course, you're going to want to buy some B200 balancing rings to go with it. But that's what's on the burner, so that's coming. I got a question this week from one of our guys, and let me see if I can quote him directly. He was asking me about making, hang on, Mr. James Clow, which I believe is Clow42 on the YouTubes. He was looking to perhaps build his own balancing stand, and he was asking me about bearings, because he's seen balancing stands with the large knife-edged wheels and the bearings, and I wanted to tell everybody what I told him, which is I played with bearings in a couple of different sizes, and with bearings that were reasonably affordable, I found them to be inferior for this application. So let me just clarify. You're going to take an arbor, you're going to stick it into your balancing wheel. Yeah. See, Wes is already excited. You're going to stick it into into the hub of your grinding wheel, and then you're going to put that on a couple of things. So the things are either bearings or Warren, in not so many words, is requesting to be excused to go watch the Stanley Cup playoffs. I didn't even know that was going on. But listen, Warren, you can catch it on the reruns. We'll be there. We'll be on the YouTubes. So you take your arbor and you either put it in a couple of bearings, or you put it on a stand that has a knife edge on each side, or a round rod, which is my preferred method, and you let your wheel balance. So when I was playing with that, I found that the knife edge or the precision flat surface or a rod was way superior to a bearing, like way superior. And by superior, I mean sensitivity. Bearings are not meant to be run at zero. Let me clarify that. ball bearings of the average variety they're not really being designed to be run at 0. They're being designed to be run at some RPM. And their static friction is, let me say effective static friction is actually pretty high. And it didn't work that well. So as soon as I went to a rolling type of a balancing arrangement, it was way better. So that's what I base all my balancing stands on. And the design that I'm doing is that. It's not a bearing-based balancing stand. And there are commercial versions of each. But, we're trying to get really fine balancing, because in a grinding wheel, in my experience, if there's an imbalance, you're going to see it in the work. It might not matter. But the problem is, as soon as you start using PFG stones, you see everything in the work. So that's where we're heading with the balancing stands. And again, part of this is going to be completely open source. And here, you can go. Carl is using the term stiction. I am not sure I would use. It's really noise. It's really noise in the surfaces. I don't know if it's stiction per se, because you're not sliding two surfaces against each other when you're rolling. It's different. Will 3D prints be part of the balancing stand? So the answer to that is yes. There was the part that I'm going to make 3D printed, I think, is going to be different than the part I thought I was going to make 3D printed. So there will be a component of the balancing stand that is 3D printed. So yes, we are absolutely going to do that. So let's talk about 3D printing. See, nice segue. Good job. K-Bonk decided to show up. K-Bonk is reporting rain and 55 degrees in the Philadelphia. Not a surprise. Thiago, welcome aboard your Sunday lecture masterclass. I'm not sure a masterclass in exactly what, but welcome aboard, sir. So, let's talk about 3D printing. So I am a huge proponent of 3D printing. If you've bought PFG stones from me, or even if you just watched any of the videos, you'll see the trays for the PFG stones are all 3D printed. And so Carl says, think about a 2-pan balance, which uses a radiused jewel knife edge on a jewel flat. Interesting. We'll talk. I'll have to study what you're saying there. Anyway, so 3D printing has been part of my shop for years now, and it's been a huge benefit. So, of course, the most 3D printed thing in my shop is the trays for PFG stones. In fact, we 3D print them, and then I do a little laser engraving on the back, which puts a date code and an ID on it. But I posted some pictures about an hour and a half ago of things around my shop that are 3D printed. And I'll repeat that here. Let me just turn on the slides. There you go. So if you're watching the video, you'll see the result here. Flat lapper. Yes, the coffee is still on. Help yourself. It's in the back. Don't use all the cream. So one of the things that was 3D printed is and this was inspired by Pearson Work Holding, my tool tag tray, which is magneted to my mill and holds all the tool tags. That is 3D printed, and I based that on a design from Pearson, and that came out great. It has 16 slots. I have 16 tools. All of my 1, 2, 3 blocks and ground angle thingies are all in their own custom trays. And finally, this stupid little tray. This is a tray meant to hold 3x5 file cards and 2 writing implements. In this photo, it shows a Sharpie and a highlighter, but normally I have a Sharpie and my Saga pen from Grimsmo Knives. And that actually went through about 4 iterations, and this is the one I like. And this is planted in about 4 different places around my house and shop because I like 3x5 cards. So that's another very, very useful one. Another one is, and Chris got all excited about this, spare battery holders. CJ, I will tell you all about it. So I found there's a couple of ways to go about 3D printing. One is you design it yourself, you print it, you use it. Another one is you find somebody else who designed it and made it open source, basically publicly available, Creative Commons licensed, and you download their model and you print it. And yet a third way is to download a model from somebody and remix it, so to speak. So if you're watching the video, there's this little spare battery holder that I made. This is somebody else's design. It's a lovely design. All I did, it was originally designed for a AA battery. I scaled it. I actually scaled it in my slicer to be the right size for the 1, 2, 3 batteries, and boom, it was perfect. So that's another application. K-Bonk, I'll answer your question in a sec. Here's another one. This is awesome. I have them right here. This design has been around. This is a wire winder. So the guys who fly kites have these things, right, for storing their kite string on it. But us antenna guys have found out that it is a fantastic way to store wire of various lengths or types, and it keeps it ready to use in the field. And of course, I have a cheapo carabiner on there. Very, very useful. And I've started 3D printing those, and those were right out of the gate. They were perfect, and those came off of printables.com. Printables is the Prusa version of Thingiverse, and I like it. Now, again, I posted this on Instagram, but the part number of that bungee material is what I use in this design, and that holds all the wires on. It's very clever, very, very useful. Again, all 3D printed. Okay, answering some questions. Okay, Carl, we'll have to talk about this. I'm not picturing it, but I'm very, very interested to hear more about this balance type. CJ Stevens says, you have that first layer nailed. Thank you very much. What type of build plate are you using? I'm running the Prusa Mark III, i3 Mark III with the smooth steel build plate. So it's a steel plate coated with a layer of PEI, polyether imide, and it works great. And it's double-sided. You can use the top or the bottom. And I flip them. I try to flip them every batch. I just flip it over. That makes them last longer. And they work out really well. And for the guys watching the video, right, this is the top surface. All right, let's see if we get a little light action there. All right, so you can see the printing marks, okay? And then here's the bottom surface. And I know this is not a 3D printing tutorial, right? But the bottom surface should not be perfectly smooth. You should see a little bit of line between your rows. And that's working out really well. So yeah, once you get it, you get it. See my previous video entitled Reliable PETG on the Prusa. It's in the YouTube feed. K-Bonk asks, any PLA or all PETG? This is an easy question to answer. All PETG. I print very, very little PLA these days. I actually kind of avoid it. So I'm 100% PETG. I'm also not using any of the fancier filaments. It's a great material. It'll handle UV. It'll handle moisture. It's a fantastic material. It's strong as all get out. It's not as stiff as PLA. So if stiffness per se is what's important, there's other materials that'll make it stiffer. For me, it's been PETG all the way. Yeah, so now the Prusa also came out with a textured build plate, so that when you pop it off the plate, the bottom has this cool texture to it, and they actually use that in the manufacture of their printers. Not interested. Never, just not interested. The Prusa system has been outstanding as far as the build plate, and I have burned through a couple of plates. I've worn them out. Flatlapper says, I really want to get a printer, so I am in sponge mode. Well, let me tell you, there's a lot of excitement going on right now about these printers from Bamboo. So Robin Renzetti just bought one. John Saunders bought one. They're popping up all over the place. And the reason it's a good printer is they've used all the sensors. They've got a camera in there. I believe they have LiDAR in there. They've got what they call input shaping, which really is sort of resonance compensation in the printer with accelerometers. There's a lot of smart design in there, and you get it all for about $1,500 plus or minus. So it's a tiny bit more expensive than the Prusa, than the new Prusa, the Mark IV, which is out. I don't know. I know what I learned in videos. That's all. Looks good. I mean, I'd buy one. People are getting excited about 3D printing now because it is perceived and perhaps true that this Bamboo printer is just push the button and go. And that's cool. So I don't have any negative things to say about it. I talked about it last week, so I don't want to do it again, but I don't think you'll go wrong with one. I don't think you'll go wrong with a Prusa. And I would get the Mark IV. So, let's see. So, I think I answered your questions about my process, but making stuff for the shop is routine around here, especially if we have a bunch of small bits and pieces and we suddenly realize we have to keep them organized. We'll make a little sorting, a little tray where everything has a place to go in the tray. One thing I have not started doing, and I know others have done it, was play with this Gridfinity system, mostly because I've been using Schaller bins from the Schaller Corporation, Worcester, Massachusetts, right up the road. And they make these injection molded bins. They ship them to you lightning fast. I mean, literally, you almost have it the next day. And I've been using those for parts storage. And to think that I would spend time 3D printing one of those doesn't make sense for me. However, the Gridfinity system looks interesting and is worthwhile. Another thing, and this is for Flatlapper, right? Because K-Bonk says it's a pain in the ass when you swap out types. This is true. Let me tell you my position on PLA and versus PETG, because I had to figure this out myself. PLA will oxidize. So if you get PLA too hot, it will oxidize just like, and turn brown and hard and crusty. The problem is, once that happens, it ain't going away. it is really hard to get rid of. And once it oxidizes, it's not a plastic anymore. I don't know what you call it. You chemists out there will probably inform me, but it becomes not a plastic. Let me put it a different way. Not a thermoplastic, right? So it's not going to melt again. Once it oxidizes, you're toast. So PETG won't do that. PETG is a thermoplastic up to, very high temperatures. So if you switch, let me personalize this. I don't want to be too general. If I switch from PETG to PLA, okay, I run the risk of having PLA contamination in my print head. And if I go back up to PETG temperatures and oxidize that PLA, I'm toast. I probably have a clogged nozzle, and I have some maintenance to do. So I avoid PLA, and when I do use PLA, I'm very careful to run a cleaning filament, which I believe is, actually I'm not 100% sure what the material is, but it might be a UHMW kind of, that's what it feels like. And I just run a bunch of cleaning filament through at high temperature, well, at first at low temperature, then at high temperature, to clean out any trace of PLA before I switch back. So those are things you have to think about. Also, PLA will not do well in a UV environment, and I don't think it will handle oil very well. Not 100% sure on the oil, but definitely on the UV and moisture outdoor environment, PLA is not useful. So if you're making minifigures, or if you're making a prototype where you need very fine detail for, maybe fitting things together or show and tell, fine. But if you need something mechanical, that is rugged and you can yank on it all day, PETG is the way to go. K-Bonk asks, are you running a 0.4 millimeter nozzle? It's not a NOS. NOS is a trademark of Kinetic Precision. I am running a 0.4 millimeter nozzle. Yes. Now, a little side story here. Eddie Reese, who you might know from Saunders Machine Works, he encouraged me to go 0.8 millimeter for the trays and stuff, because it'll be faster and I didn't need the detail. And he was right. It worked out great. But I did that on a Taz 6 printer that I had. And when I went to all Prusa, I decided to go all 0.4 millimeter. So that's what I'm doing, all 0.4 millimeter. Oh, here we go. I knew Carl would jump in here. He says the material is cross-linking, which hardens it. Further heat exposure will cause loss of molecular weight to chain breaking, which causes friability. You just said it was going to get hard. You just used more words. Carl, I so appreciate your wisdom on this, because I do not have the picture in my head that you have in your head of these here molecules. But yes, so there's your difference between PLA and PETG. Let's see. So there are also, I will point toward Adam Demuth's videos on making some cool 3D printed things. Go check it out, and I that's also worth looking at. So we haven't talked about resin printing, and that's because this is not about resin printing. And in fact, I want to encourage people like Flat Lapper, who are first looking at getting a 3D printer, and you're wondering, hey, I'm a tool maker, or I'm a machinist, and how is this going to be useful for me? And the answer is, yeah, it's going to be useful for you. Like wicked. All right, so let's see if there's any other. I took some other pictures for you guys this week. Oh yeah, so let me show you what I'm talking about. This is This is what it takes to change a, I posted this on Instagram, to change a nozzle. It looks like I'm in an operating room with all my implements laid out. But this morning, it looks worse than it is because it took me about 10 minutes and I changed out a nozzle, which was pretty gross looking. And it turned out that I had 6 months on that nozzle and just needed to change it. So I changed it. And, again, if you're willing to do maintenance on your stuff, it'll last forever. So let's see if I have any other slides. Oh, here's some pictures. Again, if you're watching the video, here you go. If you're not, I can't save you. Here's some pictures of those parts, those wire winders that I made, and the battery holders in process. So the battery holders, I was running 3 of each size, 3 sizes, so 9 battery holders per tray. There's the whole farm last night. So I was making the wire winders and the battery holders. So in one bench, you could easily put 3 Prusas and crank stuff out, which is what I do. So there you go. All right. So you guys have any questions? We can happily address some of the questions on any topic that we have covered. I don't know if I missed anything. So while we're doing that, I wanted to show you guys something. This is off topic as far as machining is concerned, but I'm sure I'm going to hit a few nerves on this one. I bought a new radio. Now, I'm a ham radio operator, and that's why I design antennas. I've been doing antenna design for 25 years, and I do consulting in antennas, and I think you guys knew that, but if you didn't know that, that's sort of the day job. So I bought this new radio, this new ham radio from ICOM, and I've eaten dinners that have been bigger than this radio. This is the whole thing. This is the whole radio. Okay. It even runs on its own battery, or you could run it on an external battery. But this is called an ICOM 705, and the technology that's in here is absolutely ridiculous. And by ridiculous, let's see. Yeah, I mean like totally ridiculous. Okay. And the wire winders that I just made are part of my kit for my HF antenna to go with this radio. So yesterday I got this radio up and running, and I went out to the front yard and I sat in the grass and I put up this pole. I won't get into that right now, but I ran a wire antenna up a portable pole and talked to my buddy in Maine. It took me 15 minutes to set up, and I was using a radio that's 1/2 the size of the radio that I started ham radio with back in the day, and the technology in there would have been just mind-blowing. Flatlapper says, I think my biggest current issue is picking a brand / manufacturer. I really think I would recommend the Prusa. The Prusa is open source. Every part in it is open source. So if you break a part, you can print a new part, which is ironic because you have to have a printer to print a new part. Their customer service is very good, and they're in Czechoslovakia. I'm sorry. That was bad. They're in the Czech Republic. So, and I've talked to those folks, and they're very nice, and they're very supportive, and their online support is excellent. The new Bamboo is got, sexy new technology. It's a Chinese company that professes to have an office in Dallas, Texas. People like the printer. A couple of people we know have the printer. It's still young. So I've had a Prusa printer for years. I have 2 different generations. I upgraded the older one of my 3. I don't think you'd go wrong with the Prusa. As far as all the knockoffs on the market, not interested. I know people get $200 printers and $150 printers, and no, not interested. If you were buying a new 3D printer, would you go opened or enclosed? I have been running PETG surprisingly, it shocked me, on an open, non-enclosed printer now for years. And I think I'm over the enclosure. It works just fine. If it was no cost and no effort, I'd go enclosed. But my experience has been excellent with PETG on the open Prusa. K-Bonk says, I got a Creality V2, nice entry machine, using the Prusa slicer for it was a game changer. So there you go. There's the Creality. I've heard good things about the Crealities, but like I said, Prusa, very happy. Flat Lapper says, so a closed printer allows you to do some of the materials which require higher temperatures more reliably. For example, ABS, which I have an opinion on, ABS requires higher temperatures and absolutely needs an enclosure. My buddy Adam, MHM Machining, he does a lot of ABS. He's an expert in using ABS, and he knows all the vagaries. Enclosure is very important. You get a breeze, it's not going to work. However, ABS is starting to look like not a great material for some things with some of the new alloys that are out there. So if I was of a mind to want to be a 3D printing enthusiast, in other words, I'm 3D printing for the 3D printing, I would say, sure, an enclosure so you could do all the fancy filaments and do all this stuff. That's not me. I'm really happy with PETG parts, and I don't need it. So I'm not too excited about it. Now, having said that, my first printer, I built an enclosure for. And I was all about the enclosure. I had 2 different flavors of enclosure. I had an enclosure on the Taz 6. But now, and the thing that changed my mind was that when I got my first Prusa and I looked at Prusa's printer farm making the parts for the Prusas, they had a room that wasn't, the only enclosure was the room, and they had 50 printers in it. So I said, gee, if they could do that, I could do that. And sure enough, I could do that. So, yeah, K-Bonk, I don't want to get into politics here, but the bamboo slice, he says the bamboo slicer has the Creality V2 presets listed on it. Makes you go, Well, I just heard a podcast. I listened to 3D Printing Today, and those guys were talking about the fact that Bamboo was taking open source stuff and closing it. So they're sort of standing on the shoulders of people that have gone before them in the world of open source, and they closed it. So I don't know. Anyway, there you go. I think you know everything I know about 3D printing at this point. Happy to help, Jeff. We're coming up to the top of the hour. I'm going to have a sip of tea, and if you guys put a challenging question in there, I'll try to answer it before we have to say goodbye. Robert Simpson, any experience with metallized filament for shielded electronics enclosures? It's really funny because as an antenna guy, I frequently have these conversations, not frequently, but I have these conversations with 3D printing companies about their ability to print conductive filament and, hey, we can make antennas. Would you be interested in working with us? And on at least 2 occasions, I said, yes. One was a printer company whose name I will not mention, but they were they weren't exactly a flash in the pan, and they forged their own way. And I said, yeah, let's do it. You guys have a good printer and you can print 2 different filaments, and let's go. I will design an antenna for you to show off your capability. And radio silence. So they went away. Another company came to me. There was a filament company, and I think I gave you bad information. It wasn't Flash Forge. It was Mark Forged that I wasn't going to mention their name. Again, a great company. Don't know why they went radio silent. Another company was a filament company. I genuinely don't remember their name. And they came to me, hey, we have this groundbreaking conductive filament. Would you be interested? And I said, well, can I run it in my Prusa? And they said, absolutely yes. I said, I will design an antenna that highlights your filament and we'll make something work. Radio silence. So I've never gotten anywhere with doing that. So I have no experience with the metallized filaments, but I will tell you that I do not expect any filament to be a very good conductor. I would expect there to be filaments that are somewhat conductive. And from a ESD point of view, or static discharge point of view, probably effective. From a shielding point of view, I don't know. I don't think I'd be too excited. Now, keep in mind, 3D printing as a big umbrella includes 3D printing metal, right? And that's that's not what we're talking about. We're talking about a Prusa with a filament in it, and oh, by the way, this has metal in it. And that particular technology has not impressed. So that's all I know about that. All right. Well, hey, top of the hour. How did we get here? Thanks for tuning in. Thanks for participating. I appreciate you. This podcast will be, this video will be a podcast. And if you don't see a video in front of you and you're just listening to it on your ears, it is a podcast. So this will be up as a podcast. This is sponsored by PFG.Stones.com. If you're not using PFG Stones, you're not flat enough. If you guys have questions, topics, anything that you want covered, or guests, I guess it's time for bringing some guests back. Let me know who you want to see. So K-Bonk says, have you heard about the advanced lab at the University of Maine? I assume that's Orono. Running an Ingersoll master print, just printed a 25-foot, 5,000-pound boat. I have not, but I am also unsurprised. And that sounds really cool. I don't use ball bearings. I thought I said that. Any ball bearing experts here? It depends on the application, I suppose. I have not had any sufficiently critical ball bearing requirements to have any expertise. CJ Stevens reminds us to say, hit the like button before you go. So if you're watching us on YouTube, please hit the like button. Please subscribe. And please send me a message saying what you'd like to see more of. And if you're listening to the podcast, you have a little earwax I think you need to take care of. Okay, I'm just saying. We'll see you guys next week. Have fun. Go make something, and we'll catch you then. Ciao.